Okay guys, we are floating at Geometry Notes 9.5 and we're going to be working on um, use a scale factor to make a larger or smaller copy of a figure that is similar to the original. These look like dilations. And by the way, they are. A dilation with center C and scale factor n. N is greater than 0. Remember, if n is greater than 0, this value n, it's going to be, oops, we're going to undo that. It's going to be an enlargement, okay, is a transformation with these two properties. The image of C is itself, that is C prime is equal to C, okay, and if I've got the image of C is itself, we're talking about this spot right here, so our center of dilation. Okay, for any other point R prime is on segment or ray CR, so I got CR where I've got R and R prime. Okay, and CR prime, the distance from C to R prime, okay, is equal to n times the length from C to CR. Okay, now, or we can look at it as n is equal to CR prime over CR, which is image divided by pre-image. And we can set that up to find our letter n, our value for n, where that's our scale factor. Okay. The image of a dilation is similar to its pre-image. Notice they're similar. Okay, I want you thinking the iris of your eye, it dilates, it grows or it shrinks, but the resulting images will be similar. Okay, so if I have a point here and I have this point here, this is between C and the original. Okay, I have my pre-image to my image, and this is P double prime, Q double prime, R double prime. This is where my n is smaller than 1. And when I have my n greater than 1, I'll have an enlargement. And again, I've got to stop clicking on that. A dilation is an enlargement if the scale factor is greater than 1, and a dilation is reduction if the scale factor is between 0 and 1. I say that because if it's negative, it's actually a 180-degree reflection, but whether it's a reduction or enlargement with a 180-degree rotation all depends on its absolute value in comparison to 0 to 1. And if it's between 0 and 1, the absolute value, it is a reduction. If it's greater than 1, it's enlargement. If n is exactly 1, it's just the same thing. So, number 1A, when we're setting this up, we're talking about this original shape. I got A, B, C, D, going to A prime, B prime, C prime, D prime. And here, remember I was kind of crazy about, we're going to grow C to C prime, and I was always talking about corresponding sides. Look at it, DC and D prime, C prime, corresponding sides, corresponding sides. So when I set this up, I've got N is equal to the image over pre-image. Well, the image is the big thing, the blue thing. Okay, that was my primes. And I'm talking about corresponding sides here. Over the pre-image. Pre-image is 2, image is 4. What's 4 divided by 2? Well, it's 2. So I've got an enlargement and with a center A, okay, so the A was the center of my enlargement, and my scale factor is 2, and this is how we get my 2. So here, I have a center of enlargement that's C, and I'm having a reduction because it's going from big to small. So corresponding sides, okay, image to pre-image. Remember, image is its final resting place, so 2, okay, image over pre-image, so I've got 2 over 8, which is equal to 1/4. Now, keep in mind, corresponding sides, image over pre-image. Now, that's a formula. Now, I'm looking at C. This looks kind of confusing, but keep in mind, P is my center of reduction or enlargement, whatever is going on here. So if I go from P to L prime, so, oh, hey, look, this is L and this is L prime. So this is my image. This is my pre-image. So this is my pre-image length, and this is my image length. Okay, now keep in mind, sides are variable. They'll change in size. but angles are always the same. So when I'm looking at these, we got to pay attention to that. Okay, so right now, if I talk about my image, n is equal to p to l prime. I'm going p to l prime, p to l prime, and I've got p to l. I've got, well, 4 over 2. So I have my size change is 2. I got a scale factor going on. So L prime, M prime, N prime is twice as big, okay, as LMN. So if I want to solve for x and I have x here and x plus 3, remember x plus 3 is twice as big as x. So 2 times x is equal to x plus 3, and I can solve and find that x is 3. So this is 3, this is 6, okay? And that makes sense because if that's 3 multiplied by 2, it's 6. Now, also you got to keep in mind as we're going through here, I'm thinking about the fact that I've got angles. I've got angle y and angle 2y minus 60. Keep in mind, angles are congruent. Sides are variable based on scale factor. So the angles are set equal. And I solve for y here, and it's negative y equals negative 60, and y is 60 degrees. So this is 60 degrees, and so is this, because 2 times 60 is 120 minus 60. Now, as you're working through, there are other ways I could do this. I went through chapter 7 and I have 4 to 2. I got a 4 to 2, big to little, and so I got x plus 3 to x plus 3 to x, big to little, and I cross multiply and say 4x is equal to 2 times the quantity x plus 3, and I can solve that and find out that 2x is equal to 6, and guess what? Yet again, x is 3. That's another way for us to apply the things we already know to this situation. Okay, now sliding on here. Another example problem. You're going to notice that today's notes is all about example problems and how to set them up. And remember, we have triangle x prime, t prime, r prime is a dilation image of triangle XTR. The center of dilation is x. Is the dilation an enlargement or reduction? Well, if this is a size change and it's the image, of this image of XTR, so this is x prime, t prime, r prime is a dilation image of triangle XTR. So this is my final resting place, and this is my original thing. So I went and blew it up, okay, with a size change is the center of size change around x and x prime. Okay, so I'm going to be going from XTR to x prime, t prime, r prime. How far apart is x to t? It's 4. How far is x prime to t prime? It's not just 8, it's 4 plus 8, which is 12. So I'm setting this up for my scale factor. I've got x prime to t prime on top and xt on the bottom. So I've got 12 to 4, it's 3 times bigger. It's an enlargement, it gets bigger, and that's how I make the decision. Keep in mind it's not 8 to 4, and that's a real common mistake, and people will get it wrong because the distances are from this point of where the dilation, the center of dilation, which is here x and x prime, they're the same point. Now, same problem here with this origin being our reference of size change, and I'm going to use corresponding sides. I could also use distance. I could use the distance from the origin, which is 3 and 6, to set this up as well. But either way, I'm going from JKLM to J prime, K prime, L prime, M prime. So that means that it's going to be a reduction. It's going to get smaller. How much smaller? My scale factor is decided by N, which is KL prime, K prime L prime over KL. So I got K prime. Where's my K double prime? K prime L prime and my KL. So I'm going to go 2 over 4, and my size change is 1/2 for my scale factor. So it's 1/2 the original size. So that's our answer. We've answered it. It's a reduction, and our scale factor is 1/2. Now in 9.5, all dilations in the coordinate plane in this textbook have the origin as the center of dilation. The dilation image of point P xy can be found by multiplying the coordinates of P by the scale factor n. So if I have P of x, y, that's going to be mapped onto P prime of nx times ny. Wow, I'm just multiplying my scale factor times my coordinates. That's all I have to do. Okay, so we got this, and it's going to be this much bigger, so I'm just going to multiply by n, and my coordinates are multiplied by n, and that's how we adjust it. So keep in mind, it's a rule. xy becomes nx, ny. And if I already know the scale factor is 2, and I do, it's right there, I can just go 2 times 2, which is 4, 2 times 0, which is 0, and that's what I'm doing. 2 times negative 3, negative 6, 2 times 1, 2. 2 times 0 is 0, 2 times negative 2, negative 4. Crazy. And I noticed that it is an enlargement. Well, that kind of makes sense. You guys go ahead and do number 5, turn me off, and then turn me back on. Okay, now that you're done, check it out, man. We got xy becomes nx, ny, and our scale factor is 1/2. So half of 2 is 1, half of 0 is 0 still. Okay, half of 3 is 3/2 or 1.5. Okay, as we're going through this, apparently I've moved those down, and half of 1 is 0.5. Half of 0 is 0, and half of negative 2 is negative 1. Okay, well, it makes sense. Let's graph it. Hey, look, it's smaller. This is a reduction. And we kind of thought it would be a reduction because the scale factor was less than 1. Now, when we're doing this dilation has center 0, 0, it's always the case, and then find the image of each point for the given scale factor. Well, if I've got this point, and this is my scale factor, I'm just going to multiply them together. So it's 2 times negative 5, 2 times 1. That's all I'm doing. And this happens to be an enlargement because the scale factor is bigger than 1. Here, this happens to be a reduction because the scale factor is less than 1. So I multiply 1/3 times 0 and 1/3 times 6. I end up getting 0.2, and that's reduction. And here I've got m is 0, 0, and it's an enlargement, but the points is 0, 0. Okay, but it still will be an enlargement because my scale factor was bigger than 1. In problem 7, a magnifying glass shows you an image of an object that is 7 times the object's actual size. So the scale factor of the enlargement is 7. If an apple seed is 1.75 inches long under the magnification, what is its actual length? So I'm setting this up a little different. Remember, it used to be image over pre-image, but I just kind of went n times the pre-image, and they're asking for the actual length, and I know n is 7, so if I take 7 times the actual length, I get my image. My image here in this problem is 1.75, so I can set this up, and p I'm using as pre-image. Now if I divide by 7, I find out that p is 0.25 inches, and why did I know it was inches? It's because it was 1.75 inches, and it's a linear problem, so it's still inches, and I could got a word problem, I got a word answer. Actual length is 0.25 inches. And remember, I'm still using the idea that n is equal to image over pre-image. I just packaged it a little bit differently. Now let's go on to problem 8. Problem 8, the height of a document on your computer screen is 20.4 centimeters. When you change the zoom setting on your screen from 100% to 25%, the new image of your document is the dilation of the previous image with a scale factor of 0.25. What's the height of the new image? I'm going to set it up like this. Okay, my pre-image is 20.4, my n was 0.25. Okay, my image is what I'm being asked to find. Well, I just multiply those out now, and I'm able to find that my image is 5.1, and word problem, word answer, new image height is 5.1 centimeters. Okay, now that's the end of notes for 9-5. I hope things are going well. If you have questions, you ask us in class. Have yourself a super day.